Hey, hi everyone. Welcome to HNM Technologies online training. Let me start with a fun idea. Have you seen Russian dolls, like the Matryoshka dolls? You open one, there is smaller one inside. Open that, another smaller one. Keep going until reach the thinnest doll that can't be opened. We saw in mostly in Rails. That method is called a recursion. A function that opens itself finds another version of itself inside, keeps going until it hits the smallest case. So let me write a function like this. If size is 0, then I print find the smallest one. I'm just returning that. Then I print. Then I'm printing after return. I'm printing opening a doll of size of size, and the open doll. I'm the calling the function, and the size is a size minus one. Okay. Now I'm calling my function open doll. So I'm just have to give a my argument is a value 5 because the parameter is a size. So any size I can give. So now I'm giving 5. See the output is opening a doll size 5, 4, 3, 2, 1 and found the smallest doll. And if I give size 7, yeah, it starts from 7, 7, 6, 5, 4, 3, 2, 1 doll. And if I give 8, like that only. Any number, any parameter or any number I can give in my parameter. Here in my parameter I can give any value because the here I can give any value in my argument because the parameter is a size. So sizes can be anything. Okay. And see here function calling itself is a recursion. In this video we're going to cover first what is a recursion and how it works. Then second, base case, the most important part, and third, factorial, classic recursion example, and fourth, Fibonacci series, the famous number sequence, and fifth, how Python handle recursive calls, and sixth, when to use recursion versus loops. Okay, we'll see every topic step by step. See, what is a recursion? Simply, a recursion is a function that calls itself. Recursion is nothing but a function calls itself. You already know a function call other functions, right? Recursion is just a function calling its own self. Normally, for function calls another function like define a function called b, and that function printing that I am b, right? Then I created another function called a, defining function a and printing I am a. So function A's work is printing I am a and then calling function b. We'll see if I call my function a, so it prints I am a, I am b. It actually print the print statement, then b calls function b. Function b's output is I am b. So here you can see this is how a function calls another function. But actually recursion is I try to I'm defining a function a. Recursion is calling function itself. So that means I define a function a and then calling a. So if I call my function a, you can see the output terminal is a recursion error, maximum recursion depth executed. So here what happens when I call my function by itself own, Python restricts the calling through 1000 times, more than 1000 times it won't called. So it's previous line repeated 993 more times. Okay, it up to 1000 times it can call, more than 1000 it can't. So we must have to give a stop condition to recursion. Calling a function itself is like standing between two mirrors, infinite reflections. To fix this, we have two simple rules. Every recursion function have must need exactly two things. One is base case, and the second one is a recursive case. Base case is when to stop, and recursive case calls itself with a smaller problem. I'll see. I define countdown. So my function name is a countdown. And if n is 0, then print blast off, then return. And I print n, that I'm printing that n, and countdown is a n minus 1. Now I give number 5. So it starts counting from 5, and then last at the end it prints a blast off. If I give my number 6, it starts from 6. 9, it starts from 9. So I'm giving a condition n minus 1. Okay, n minus 1. If the n is 0, then print blast off. This is what our output is. It starts printing 9 and n minus 1, and n minus 1 8, 8 minus 1 7, 7 minus 1 6, like this. And when it is 0, 1 minus 1 0. When it is 0, then print a blast off. Think of it like a states from step 5 to step 4, step 3, step 1 until the touch the ground. I think you got a clarity how recursion is working. Then we'll deep into the how Python handles this recursion. Our section 2 is how Python handles the recursion. Every time a function calls itself, Python saves the current call and starts a new one. It stacks them up. Once base case hits, it unwinds the backup. Think of it like a stack of plates. Each recursive call is placing a new plate on top. Base case is like stop adding plates and returning picking plates of one by one from top. Let's say that happening and define our function countdown. This is our function, right? Yeah. Then I'm formatting my output here. Started countdown from n. If m reaches to 0, then again I'm printing. Basically stopping the recursion here. Then return countdown n minus 1. What exactly our previous function did. See the output and then starting from 5 4 3 2 1 0, and here base case stopping. Then finish counting, start from 1 2 3 4 5. When countdown is 0 finishes, Python goes back to where countdown 1 was paused. When countdown 1 finishes, goes back to countdown 2, and so on. Goes in 5 4 3 2 1 0. Then the base case, then comes out 1 2 3 4 until all finishes. This is why the print after a recursive call prints on the way out, not the way in. Okay, yeah, this is a recursion. And let's see factorial. In general, factorial is n into n minus 1 into n minus 1, n minus 2, n minus 3. See here 5 factorial is 5 into 4 into 3 into 2 into 1. So this is a factorial numbers. 5 factorial is 120, 4 factorial 24, 3 factorial 6, 2 factorial 2, 1 factorial is 1. Like this we will get a factorial numbers. Each one is defined using 1 before it. Perfect for recursion. Writing a recursion for factorial, that's called a recursive factorial. I define a function name with factorial. This is the factorial of 5 factorial 120. Here, like I previously discussed, we have two steps. One is base case. This is the base case, and then after return, whatever the condition we're giving, this is a recursive case. Base case and the recursive case. Base is a stopping case, and recursive whatever the function is doing. See, if I'm printing the factorial of 5 is a 120. See here, the factorial 5 is a 120. If I give 4, it's a 24. Right. Like this, we get a factorial numbers. And now let's see Fibonacci series. And the Fibonacci series, the rule is very dead easy. Each number equal to previous to add together. Right. Like you can see, 0. And this number is 1. 0 plus 1, 1. Now 1 plus 2, 3. Now 3 plus 5, 8. 8 plus 13, 21. 20 plus 21 plus 34, 55. Like this. Sum of previous two numbers is the next number. That's the Fibonacci series. Now how to get this Fibonacci series using this recursion and all? We'll see. A different function Fibonacci and n, and this is my base case, and this is the recursive case. Here you can see I'm trying to print my Fibonacci series. For Fibonacci I call function. See here I just printed my Fibonacci number for 10 is a 55. So this way we get a Fibonacci number. And now see First we'll see the loop version. For that I define a function factorial loop result 1. Then for I in range of 1 comma n plus 1, then result multiplying with the I and then return the result. Okay. Now same thing let's see in a recursive version. Define the factorial recursive. And if n equal to 0, this is the base case, and then return what is the factorial n into factorial recursive n minus 1. Okay, this is the condition. And now let's call this to see the loop version and the recursive version. Give both the same examples. If I try to modify this 6, for this also 6, 720. So when to use which when situation simple counting or a total use loop, large numbers or a number greater than 500 like that. Also you can use the best choice as a loop. Problem naturally has a small sub problems. Use a recursion. Best is for coding interviews and exams, knowing them both. My honest advice for you: loops are simpler and faster for most problems. Learn recursion well because every coding interview asks it, and some problems like searching folders, building trees are naturally recursive. You'll see them in more as we go further. Must remember one thing: every recursive function must have two rules. One is a base case and the one is a recursive case. Base case is when to stop, and the recursive case is a call itself a problem condition. Recursive case is like a condition. Here I have three practice questions. One is write a function that prints Fibonacci series of n numbers, and then function print factorial of n numbers, and write a function that prints a sum of n numbers. Okay, use the recursion to print this. Open your VS Code and have a try. And for recursion, only two rules: base case and a recursive case. That's all recursion is. The call stack handles the rest automatically. Factorial, Fibonacci, sum of list, they all follow exact same pattern. Next video is about modules and packages. Built-in modules like math, OS, random, sys, and creating your own module. This is all I will discuss in this next class. Thank you, and thank you for choosing HNM Technologies. Happy coding.